Hi, Geometry. This lesson is on parallelograms, and this warm-up that we have here is quite intense, and if you want to do it, you totally can, but at this point in the game, I just don't really think it's worth our time. So do you want to try it? That'd be totally cool, and I'd love to go over it with you, but I am going to skip it. But I do want you to think about this question. Is every square a rectangle, or is every rectangle a square? So take a few seconds and think about that. All right, so is every square a rectangle, or is every rectangle a square? What did you come up with? Every square is a rectangle is correct. Now we'll talk about why that is, but that's a pretty popular logic question. So first of all, what is a parallelogram? Well, in the word parallelogram, it starts with the word parallel, and so it's a figure in which the opposite sides are parallel. And it has to be a quadrilateral, which means that it has four sides. So a parallelogram is a four-sided figure in which the opposite sides are parallel. So here is an example of a parallelogram. And we draw parallel, remember, with those arrows. So to show that these are parallel, I put two arrows on both of them. And then to show that the vertical ones were parallel, I put one arrow. So that's how you tell if, or how you notate if things are parallel, which you know. And that is what parallelogram looks like. But it can also look like a rectangle. So a rectangle is a quadrilateral, meaning it has four sides. So a rectangle has four sides with four right angles. So the special thing about a rectangle is that it's a parallelogram, meaning its opposite sides are parallel to each other, right? These are parallel and these are parallel. But it's not slanted like this one above. It has four right angles. So that's the difference there, is it doesn't have the slants because it has right angles instead. A rhombus is another parallelogram, and it has four sides that are congruent. So see how they have the tick marks on them? These are congruent. So this is parallel to this, and this is parallel to this one, opposite it, which makes it a parallelogram, but it also has congruent sides. All four are congruent. Now when you put those two characteristics that make these shapes unique together, so four right angles for a rectangle, and then four congruent sides for a rhombus, when you combine those, then you get a square. And a square is a quadrilateral, or a parallelogram. So the opposite sides are parallel, and it has four right angles and four congruent sides. So therefore every rectangle, oh wait, this is the typo. Every square is a rectangle, a rhombus, and a parallelogram. So a square is a rhombus. Why? Because all it has to do is have four congruent sides to be a rhombus. Every square is a rectangle. Why? Because to be a rectangle, you just have to have four right angles. And to be a parallelogram, your sides have to be opposite. So a square is all of those. But yet all of those cannot be a square. All right, so we're going to get into some tricky like thinking here. Giving true or false to these statements. So this is really just going to help make sure that we understand what these definitions are. So we're just going to do the true and false for these. So these are if-then statements. If a quadrilateral, so if a four-sided figure is a rectangle, then it is a parallelogram. So what is so quad means four sides. Rectangle means four right angles. I'm going to just do that for a right angle. And then parallelogram means the opposite sides are parallel. So is that true? If it's a rectangle, is it a parallelogram? Yes. So that is true. Maybe I should have read the directions. Decide whether the converse is true or false. Okay, so this statement's true. Is the converse true or false? So if a quadrilateral is a parallelogram, is it a rectangle? If it's a parallelogram, if it has parallel sides, opposite sides, does it mean that it has four right angles? No. So the converse is false. So I'll just do the statement here and then the converse here. Okay. Number 2. If a quadrilateral is a parallelogram, then it is a rhombus. So four-sided figure, parallel sides, does that make it a rhombus? No. Why? Because what does a rhombus have to have? A rhombus has to have four congruent sides. Just because the opposite sides are parallel doesn't mean they're congruent. But if we make the converse of it, if a quadrilateral is a rhombus, then is it a parallelogram? Yes, it is. It has to be. Because that's what a rhombus is. A rhombus is a parallelogram. If a quadrilateral is a square, then it is a rhombus. So a square has four right angles and it has four congruent sides. I don't really know how else to write that. And then if it's a rhombus, that just means it has four congruent sides. So if a quadrilateral is a square, does it make it a rhombus? Yeah, it does. A square is a rhombus. But is a rhombus a square? No. A rhombus isn't a square because a square has more restrictions. A square has to have equal sides and right angles. A rhombus doesn't. Just has to have equal sides. If a quadrilateral is a rectangle, then is it a rhombus? Is a rectangle a rhombus? Is a rectangle something with four right angles? Is that a rhombus? No. But is a rhombus a rectangle? No. You have like opposite requirements. If a rhombus is a square, then it is a rectangle. If a rhombus, so that means it has four congruent sides, and then it's a square, so yeah, then is it a rectangle? Yeah, is a square a rectangle? Yes, so true. If a rhombus is a rectangle, is it a square? Yes, because a rhombus requires four congruent sides. A rectangle, has four right angles. And so if we say it has this and this, then does it make it a square? Yeah, so that's why the converse is also true. Okay, so basically, one thing that we can get from this is that a rhombus is a square if and only if it is a rectangle. All right, so we have some theorems that come along with parallelograms, and these help us prove that something's a parallelogram. And we often have to do proofs to show that a quadrilateral makes a parallelogram, or then that different things about it are congruent, so we can use that to solve for things. So these are the things that we can get from a parallelogram. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are they parallel, but the opposite sides are congruent to each other. So that means if you had like x here and you had 17, well, what's x equal? 17. So if it's a parallelogram, then the opposite sides are not just parallel, but also congruent. And so they have an example here. If you have PQRS, which is a quadrilateral, so if it's a parallelogram, then PQ is congruent to RS, and QR is congruent to PS. The next one that we know is that if a quadrilateral is a parallelogram, then the opposite angles are congruent. So not only are the opposite sides congruent, the opposite angles are congruent. So Q is congruent to S, and P is congruent to R. Okay, if a quadrilateral is a parallelogram, then its diagonals bisect each other. This is a really popular one. So here's the diagonal. Its diagonal is cut in half by this other diagonal. So that's cut in half. So you have to know that these lines are diagonals, and if you do, then you know that they're going to cut each other in half. Now, this also leads to something else that we can see, that, hey, if these sides are also congruent to each other, then we've got 1, 2, 3, 4. We've got congruent triangles in here, right? Like this angle, these are vertical angles. So you can prove that triangle QMP is congruent to triangle SMR. And all the other triangles as well are congruent because of side angle side, or side, or yeah, that's it. So that follows as well. So we know that the diagonals bisect each other, but then we can also use that for triangles. Another thing we know is that the consecutive angles are supplementary. So remember that this is a parallelogram, so this is parallel to this. So if you have your transversal going through it, remember what we know about consecutive angles, they're interior angles, they're supplementary. They equal 180. It also makes sense because there's 360 degrees in this figure, as we learned from our last lesson. And if these are congruent, if X is congruent to X, or Q rather is congruent to S, and this P is congruent to R, then they have to split those angles up equally. So it's kind of interesting. We know that the the consecutive angles are supplementary. They equal 180. All right, so we're going to practice using those things to solve a few problems. So it says, find the indicated measure in parallelogram EFGH. Explain. So the measure of angle EJF. So I want to find this angle. Interesting. Well, let's see what we know. We know that this right here, it looks like this is 60. So this is a straight line, so that would be 180. So that must mean that J is 120. Because it forms a linear pair with that angle FJG. And so if this has to be 120, this has to be 120, and this has to be 60. Okay, find the measure of angle HFG. Okay, so this angle right here. Well, that angle is congruent to this angle right here, because of parallel lines, and then cut by that diagonal could be the transversal. So let's see, if we know, I'm going to erase some of this stuff because it's getting crowded in here. We know that this is 60. Well, we could use our triangle. Every triangle has 180 degrees, right? So 180 minus 85 minus 60 gives us 35. So that has to be 35. So this is 35, which means this is 35. Oh yeah, and also this is 85 because that's 85 right here. And they are parallel lines cut by transversal, and those are the alternate interior angles. Like if you see this is parallel to this, and if your transversal is this thing, then these are alternate interior angles. Okay, angle HGF. Angle HGF is 45 plus 85, so 130. The measure of angle EGF. Found that already. GEF. Oh, well, if this is 45 here, then this also has to be 45 because those are alternate interior angles. And then, Marky, shh, it's okay. So then EHG. Oh, okay, so 35, well, what's 85 plus 45? Didn't I just do that? It's 130. So this is 130. So I know that E plus H should equal 180. So that has to be 50 then. So we got to use a lot of what we just talked about for this. And I know that could be a lot to like do while I'm doing it. So if you want to, just go back and see if you can figure those out on your own and check your answers. Because sometimes it's hard to like follow when someone else is processing as well. So just feel free to go back and try that again on your own. So in this diagram, QRST and STUV are parallelograms, which just means opposite sides are parallel. Find the values of X and Y and explain your reasoning. So X is the side, and Y, okay. Let's see. This is 40, this is 40. And like S plus V should equal 180. Or also s plus t should equal 180. So let's see, we can figure out why, because if I do 180 minus 80 minus 40, that's 60. So y equals 60 degrees. And then how am I going to find out what x is? Well, let's see. This is parallel to that, I know that. This is 20, then this is also 20. So isn't it 20? It's just 20. Ugh, easier than I thought. Okay, 20. Okay, the measure of one interior angle of a parallelogram is 50 degrees, more than 4 times the measure of another angle. Find the measure of each angle. Okay, so the measure of one, so it doesn't really matter which one we do, is 50 degrees more than 4 times the measure of the other one. So if this is x, that's 50 plus 4x. So then we know that these two added together should equal 180. So 5x plus 50 equals 180. So 5x equals 26. Oh, so this is 26, and then what's 4 times 26? 4 times 26 plus 50 is 154. And so then this one equals 154. There we go. Okay, so just like we talked about ways to prove that triangles are similar or that triangles are congruent, we also have ways to show that a four-sided figure is a parallelogram. So we have to use all of these things that we just said to our definitions of a parallelogram. If the opposite sides are parallel, then it's a parallelogram. If the opposite sides are congruent, it's also a parallelogram. If the opposite angles are congruent, it's a parallelogram. If the opposite sides, if one pair of opposite sides is congruent and parallel, so congruent and parallel. So remember the symbol for parallel is 2 up and down lines, and congruence like that. So if you just show one pair is, you don't have to have both pairs, just one. Or if you can show that the diagonals bisect each other. Those are the 5 ways that you can show a parallelogram, a quadrilateral is a parallelogram. All right, let's try this. So we're going to use those, I have a feeling, to solve this. The vertices of quadrilateral ABCD are given. Draw ABCD in a coordinate plane and show that it's a parallelogram. So to show that it's a parallelogram, we can use any of these things. So let's first graph it. So A is at -2, -3, over here. B is at 0, 5. Okay. 6, 1, 2, 3, 4, 5, 6, 5. And 4, -3. Okay. All right. So we need to show that it's a parallelogram. So if we go back to these, what can we show? Can we show that the opposite sides are parallel? Well, what does it mean for them to be parallel? They have to have the same slope, right? So maybe, I mean, from A to, oh, I didn't label these, darn it, B, C, D. I think we could show that they have the same slope, because from A to D, the rise is over the run. The rise is 0, and the run is 1, 2, 3, 4, 5, 6, but it doesn't matter because 0 divided by 6 is 0. And BC, the rise over the run, is also 0 over 6, so 0. And then BA, or the rise over the run, and CD, rise over the run. So how much does BA rise? 1, 2, 3, 4, 5, 6, 7, 8 over 2, so 4. And the rise over the run for CD is 1, 2, 3, 4, 5, 6, 7, 8 over 2. So 4. So we just showed that the opposite sides are parallel. So that's definitely a parallelogram. Could we show that the opposite sides are congruent? Yeah, we could do that with the distance formula. So remember, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So we could also do it with the distance formula. So if you have these points, so let's start with like -2, 3. So that would be square root of, so the first x is -2 minus 0 squared plus -3 minus 5 squared. So that gives us -2 squared, so that's 4 plus -8 squared, 64. So that's the square root of 68 is this distance. And then we can find the distance between CD. So we do 6 minus 4 squared plus 5 minus a -3, so it makes it plus. So that would be 2 squared, so 4 plus 8 squared, 64. There we have it. So 6 squared is 68. So here we're on the right track. And then this distance you can just count. 1, 2, 3, 4, 5, 6. And same here. 1, 2, 3, 4, 5, 6. So yeah, so I just proved it 2 ways. Diagonals, oh my goodness, could you prove that? That would be a lot of work, but therefore we just didn't, so I think we're good. Now, this is what you're going to work on for our homework, so these 21 questions. All right, and just ignore this. Okay, I'll see you guys soon.